Hello everyone, my name is LJ and I'm a physics teacher. So today I'm going to talk about one question in the Physicsbowl 2021. And before we start, I'm going to introduce the contest very briefly. The contest Physicsbowl is held once a year and organized by American Association of Physics Teachers. There are 40 questions here and you have 45 minutes to finish it. So this test is comparably very language friendly for those whose mother language is not English because all the questions here are multiple choices and all of them are single answer multiple choices and one out of four options. So you can see that you don't need any calculation. Oh no, sorry, not any calculation write in the test paper, or you don't need to answer any questions in the language. Okay, so here, let's check the form of this contest. So you have 40 questions to answer, but we have two divisions. And you can see in the paper, we have altogether 50 questions, and the first 10 would for division one only, and from 11th to 40th would be for both divisions, and the last 10 questions would be for Division 2 only. So there are altogether 50 questions. And the questions I'm going to talk about today is number 33, and which means that this is a must do and it's for all the students. Okay, so let's check the result of those year. Sorry, of that year. You can see that the average score is around 60, 70, right? And you can see that the distribution is pretty normal. And you can see that, okay, so let's check the top scores, the top 100. So I'll only show you the number one and the number 100. You can see that in Division 1, if you have 30 scores out of 40, which means that if you have three quarters of the questions correct, then you have top 100 rank. Okay, so let's dive into the question. Okay, so this one is about oscillation. So in this contest, we have 40 questions in 45 minutes. So which means that we have 1 minute for each question, right? Yes, there are some easy ones and there are also some tough ones. So for tough ones, approximately we need several minutes to solve, to calculate, right? For the easy ones, we can just pick the answer immediately, right? But for this one, it's a little bit complicated. The knowledge we need here is a rotational motion for rigid body. And so here, for me, I'm a professional teacher, and for me, it would take me about 10 minutes when I see it first to get out the correct answer. So I don't know for those contestants, for those students, I know there are a lot of elite students or very good students, and they can do it very well. And I don't know how much time they would spend on the test today, right? For me, it's about 10 minutes or more. So let's check out this one. The main reason that I want to talk about this question is that the answer provided by the official website is wrong. The solution is wrong. So what is the official solution? You can see here. The answer is A. To be honest, the answer is correct, but the explanation is wrong. Is wrong. It says that the sticks are the same length, so they will have the same period. It turns out to be that according to this statement, the period will be the same or it will be universal no matter where you put the pin on the stick, which means that you can put the you can drill the holes here, you can drill the holes here, you can drill the holes here, right? But think carefully. If we have drilled the holes in the center here, in the middle of the stick, what will happen? If we displace a small angle from the vertical, then release, what will happen? It won't rotate, right? If we put a little nudge, it will rotate nonstop, and we can get the answer that the period would be infinite long, right? So it could not be identical for all scenarios. So what will happen? But the answer here is still 1, 2, 1. They are the same. But the period here is, though the period for these two scenarios are the same, it's just a coincidence. It's not universal. So now let's check out how to do this one. Okay, the knowledge here we need is number one is how to solve differential equation like Newton's second law, and this is the Newton's second law in rotational motion. And here, total torque equals rotational inertia times the angular acceleration. And the second knowledge we need is parallel axis theorem, which means that if we have two axes, one of them is if we have two parallel axes and one of them is penetrated through the center of mass, and the other one just say okay, so axis O, right? So the rotational inertia between these two axes around these two axes has the relationship here, and m is the total mass of the rigid body, and the d is the distance between two parallel axes. So here, I'm going to find out the universal solution for this stick. So I'm going to set this length would be x, and for stick one, x1 equals to 4 over 12 L, which is 1/3, right? And for x2, uh, the distance between the pivot and the center of mass would be 3 out of 12, which is 1/4 of L, right? Okay, so here, let's recall the knowledge of simple harmonic oscillation. So how to solve this type of question? So for solution, so if we have, for example, like we have a spring mass system. So we have minus kx equals ma. So the all that we have, we ignore all the frictions, right? So we have ma. A equals the second derivative of time to displacement. Or if we can move m to the left, so what we have k divided by m. So what is the solution? So solution for this equation would be x equals amplitude, cosine, or sine omega t plus phi. The phi is the phase, and the omega square is the coefficient before x, which is k over m here. Okay, so this is what we learned before in simple harmonic oscillation, right? And we can have another example for pendulum. For pendulum, so for pendulum, we use this one. So if we have a, sorry, I'm going to a little bit here. If we have a massless string attached by a mass m, so if the vertical angle is theta, and then I assume that anti-clockwise to be the positive direction. Here, the only torque would be mass, would be gravity, right? The only torque would be provided by gravity. So what we have, so we have mg times lever arm. So lever arm would be L sine theta. The torque here provided by gravity would be clockwise. So that means it's negative, right? Signs are always important. It's very pivotal in in all scenarios, right? In physics. So negative signs matters significantly. So here we have a negative sign here because the torque is anti-clockwise. And sorry, the torque is clockwise, which is opposite to the positive direction, which is anti-clockwise, right? And equals to I alpha. And I alpha. Alpha is the second derivative of time of angular displacement. So now we use a small angle approximation, which is when theta is small, so theta equals sine theta, right? So we put this theta into theta, and here the rotational inertia for this mass point would be ml squared, right? So we put this L to the left, ml squared. So we have M cancelled, L cancelled. We have one more L left at the bottom, and we have G here. And on the right side, we only have the two dots here. So if we compare these two, we can observe that they have exactly the same form. They have identical form, which means that mathematically they have identical solutions, right? So what is the solution then? The solution would be theta equals theta zero, which theta zero is the maximum displacement, the maximum angular displacement, and also cosine, or you can use sine here, omega t plus phi. So omega square is the coefficient between theta, right? G divided by L. So that's why we have t equals 2 pi over omega is 2 pi square L divided by G. This is the period for pendulum, right? Okay, so back to this one. Back to this one. Okay, so if we have a small deviation from vertical, and this is center of mass, and this is the pivot, and the the distance between them would be x, and now the angle is theta. So now we have the same situation, right? According to tau equals I alpha. So what do we have? The only torque here would be gravity, the torque provided by gravity, right? And which is mg L sine theta, right? And again, this is a clockwise, so we have a negative sign. And so here we have I theta two dots. And again, we use small angle approximation. So what do we have? We have theta, right? So now the coefficient would become mgl, it's not L, sorry, it's x, right? My mistake, this is x, divided by rotational inertia, theta equals this one. Now I have the universal solution, right? So now I have the solution. So the solution for this stick would be theta 0 cosine omega t plus phi. And here, omega squared equals mgx divided by I. So now I'm going to find out what is x and what is I, right? Okay, for stick 1, x1 equals 1 over third, right? This is x1. So x2 equals 1 over 4 L. So I1 equals I center of mass plus mx squared, right? Which is 1 over 12 ml squared plus m 1 over 3 L squared, right? X2 equals 1 over 12 ml squared plus m 1 over 4 L squared. So here we have I1 equals 7 over 36. But for I2, we have 48 7/48 ml squared. And we put this two and this two into here. So what do we have? For stick one, omega 1 squared equals mgx1, 1 over 3L divided, sorry, I just use lowercase, divided by 7/36 ml squared. So what do we have? We have 7L 12G. But for omega 2, what do we have? mgx2, which is 1 over 4L, sorry, lowercase, and 7/48 ml squared. So what do we have? We have the same answer. So which means that we have omega 1 equals omega 2. So that means T1 equals T2. So we got the answer. But we can clearly see that if we have different value of x, then we will have different value of angular frequency or period, right? So here, for this scenario, for stick 1 and stick 2, they have the identical period. It's just a coincidence. It's not a universal, right? And you can clearly, you cannot say that because they have the same length, so they will have the same period, right? So how long do that take for this one? I believe I've taken more than 10 minutes, right? I'm a professional teacher and I take about 10 minutes or more to solve this problem. So how much time do you think a contester or a high school student would take in the contest? Okay, so that's all for this question. Thanks for watching. See you next time.